If you drop a solid block of steel into the ocean, it sinks instantly. Gravity pulls the dense metal straight down to the absolute bottom. Yet, the largest ships in the world are made of hundreds of thousands of tons of that exact same steel. Think about a modern mega container ship. It is a floating skyscraper that stretches longer than 4 football fields. It carries tens of thousands of massive metal boxes, heavy machinery, and millions of gallons of fuel. Logically, this massive metal mountain should plunge into the abyss the moment it touches the water. But it does not. Welcome to Hidden Engineering, where we uncover the invisible mechanics of our world. Today, we are solving one of the most famous physics puzzles in history. We are going to reveal exactly how giant steel ships manipulate the laws of physics, cheat gravity, and conquer the ocean. To understand how a megaship floats, you have to look at the water, not just the ship. Water is not an empty space that things simply fall through. It is a heavy, dense fluid that constantly pushes back against anything that enters it. Over 2,000 years ago, an ancient Greek scientist named Archimedes discovered a brilliant physical law. He realized that when an object is placed in water, it has to physically push water out of the way to make room for itself. This process is called displacement. But the water fights back. The ocean pushes upward against the object with a force exactly equal to the weight of the water that was pushed aside. This upward push is called the buoyant force. If the upward buoyant force is stronger than the downward pull of gravity, the object will float. If gravity is stronger, it sinks. So how does a steel ship create enough upward force to beat the crushing weight of gravity? The secret lies entirely in the shape of the hull. A solid cube of steel pushes very little water out of the way before it sinks. But naval engineers do not build solid blocks of metal. They stretch and weld that heavy steel into a massive, wide, and hollow shell. Inside the hull of every megaship is an enormous volume of completely empty air. Air is incredibly light compared to water. When you calculate the total weight of the steel hull, the heavy cargo, and the massive volume of trapped air, a mathematical shift happens. The average density of the entire ship becomes less than the density of the water beneath it. The massive, bowl-like shape of the hull displaces millions of gallons of ocean water. That displaced water creates a colossal upward force that effortlessly supports the heavy steel. But floating is only half of the battle. The ship also has to stay perfectly upright in violent storms. When you look at a fully loaded cargo ship, it looks incredibly top-heavy. It seems like a single strong gust of wind should flip it over completely. To prevent this, engineers use a brilliant system called ballast tanks. Hidden deep inside the double walls of the bottom hull are massive empty chambers. When a ship needs more stability, massive pumps suck millions of gallons of ocean water directly into these tanks. This water acts as an invisible, adjustable counterweight. It pulls the ship's center of gravity far down below the waterline. This operates on the exact same physics as a weighted punching bag that pops back up every time you knock it down. When the ship needs to load more cargo, it simply pumps the ballast water back out into the sea. But there is a dangerous limit to this delicate balance of weight and water. If you load too much cargo, the ship gets heavier, sinks deeper, and risks taking on water. To prevent a disaster, every commercial ship has a secret code painted on its side. It looks like a circle with a horizontal line through it surrounded by letters. This is called the Plimsoll Line. It is a visual engineering tool that shows exactly how low the ship can safely sit in the water. But the ocean is not the same everywhere. Cold water is denser than warm water, and salt water is denser than fresh water. This means a ship will actually float higher or lower depending on where it is currently sailing. The Plimsoll Line features different marks carefully calculated for tropical oceans, winter seas, and freshwater rivers. It ensures the ship never sinks past its mathematical safety limit. There is one final invisible threat that the steel hull must survive. When a ship sails through a massive storm, it encounters waves that are hundreds of feet long. Sometimes, the ship is lifted by a wave at the front and a wave at the back, leaving the middle unsupported. This is called sagging. Other times, a single massive wave lifts the ship right in the middle, leaving the front and back hanging in the air. This is called hogging. If the steel hull was perfectly rigid, the immense weight of the ship would snap the metal in half. To survive this, megaships are engineered to be flexible. The massive steel spine of the ship can physically bend and flex by several feet. It absorbs the kinetic energy of the waves and bends just enough to survive the mechanical stress. The next time you see a massive steel ship gliding across the water, do not just see a heavy machine. You are witnessing a perfect invisible balance between the crushing weight of gravity and the upward power of the ocean. It is a flexible, hollow bubble of air, wrapped in steel, built to conquer the sea. Thank you for watching. If you enjoyed this fact-based explainer, hit the like button and subscribe for more answers to the hidden things around us.